tutorial on drawing dot diagrams of ions. I'm going to start this one off with a really quick review of drawing dot diagrams of elements, because drawing dot diagrams of elements is similar to drawing dot diagrams of ions. So similar that students often make mistakes and confuse one with the other, and unfortunately lose marks as a result of this. So when we're drawing the dot diagram of the element, all we're doing is we're writing the atomic symbol of the element. So in this case here I was using calcium as an example. Its atomic symbol is Ca, and we're representing in this diagram the valence electrons that calcium has. Now there's only one rule that you have to follow for this type of diagram, is that you can only add a maximum of 2 electrons around each side of a symbol. So in calcium's case here, it only has 2 electrons, so it's going to look like this. But if I was dealing with something like, let's just say, argon, and argon has 8 valence electrons, then I would do something like this. 1, 2, 3, 4, 5, 6, 7, 8. Now, sometimes teachers will have you draw them as X's as well, so I'm using dots, but other teachers might say, look, I want you to put them in as X's. It's the same thing. They're using those X's to represent the valence electrons that the elements have. Now, oftentimes we use X's as opposed to dots, or we use dots and X's when we're drawing dot diagrams of molecular compounds, which is something that you'll learn later on in the future. Now, onward to drawing dot diagrams of ions. There's 4 simple rules that you have to follow for this. The first one is exactly the same for drawing dot diagrams for elements. We write the atomic symbol first. The next thing that you need to do is draw square brackets around the atomic symbol. The reason why we draw square brackets is to indicate that we're dealing with an ion, a charged particle. So whenever a chemist or scientist sees those brackets, they should immediately be thinking, it's an ion. The next thing we do is we write the charge of the ion above the right bracket. So again, we're superscripting the charge to the right of, above the right bracket rather. And for nonmetals, anions, again, we're going to draw 8 electrons around the symbol within the brackets. Now I'll get to that with my example as to why we do that. Perhaps you might figure it out before you even get there. To start off with, we'll start with a cation, and we'll start with sodium. So let's just write its name down. And the first step here that I said was to write the atomic symbol, so let's do that. We write the atomic symbol for sodium, it's Na. The next thing that we're going to do is write square brackets. Square brackets, then the charge on sodium. Sodium is located in group 1A. It's going to lose 1 valence electron to take on a positive 1 charge. Now, because sodium is a cation and it has a positive charge, we're not going to draw in any valence electrons around this. Why? Well, it lost it. It doesn't have any valence electrons. So sodium looks like this, or rather the dot diagram of the ion sodium looks like this. Now, if we're dealing with an anion, and let's pick on sulfur for this example. Okay, we'd start again by writing the atomic symbol, square brackets. The charge, sulfur is located in group 6A. That means it's going to gain 2 electrons to look like the nearest noble gas. Now, because sulfur gained electrons, normally sulfur has 6 electrons. 1, 2, 3, 4, 5, 6. What we're going to do is we're going to draw in an additional 2 because it gained 2 electrons to take in this charge. So that's why we have these valence electrons here, and it's also why it has the -2 charge. Whenever you draw the dot diagram of an anion, any of the nonmetals, the ions of them anyways, you're always going to include 8 valence electrons. Whenever you're dealing with metals, there'll be no valence electrons because their ions take on a positive charge, and in order to do that, they lose their valence electrons. So there you have 2 very simple examples and some rules for drawing dot diagrams of ions. If you have any questions or concerns about this, or if you need any extra help with it, please don't hesitate to contact me.